Good morning, afternoon, evening, wherever you are. Welcome to our seminar, Seaband Today and Tomorrow. This is a GVF seminar series in association with Satellite Evolution Group, and it is one of our key features in ConnecTechAsia. For those of you that have questions during our seminar, please send your email to cta@gvf.org. Today's panelists, we have four illustrious colleagues joining us. Mohanad Juard, Senior Manager of Spectrum Policy at Intelsat. Yathong Chan, Manager of Spectrum Management at AsiaSat. Mark Wardle, Vice President, Engineering and Operations at Encompass Digital Media. And Dr. P.K. Jain, Associate Director of Frequency Management at Isro. And I am your host, Greg Daffner. I'm the President of the Asia Pacific Satellite Communications Council, and I'm also the CEO of GAPSAT. The question we ask ourselves is, what do we talk about when we talk about C-band? First of all, we usually start out by talking about what makes C-band special. The quality of C-band. First of all, C-band has great qualities of propagation. And that translates principally into the fact that it has low rain attenuation, meaning that C-band signals get through even during high rainfall, which is common across most of Asia. It's great for wide area networks. A single C-band satellite beam can cover nearly half of the Earth's surface, which means that it's a low-cost and very efficient platform for very wide area networks, such as Pan-Asia distribution and contribution for television broadcasting. It's also used successfully for cellular backhaul to connect to cell sites across remote areas. And since C-band was the first fixed satellite service frequency used by satellites, we've been building reliable networks for over 50 years. So we have a lot of C-band satellites and a lot of ground facilities. But how many antennas are there? About 5 years ago, CASBA, which is now called Avia, had a study done by Euroconsult on C-band usage in Asian countries. Euroconsult concluded that there are between about 17 to 30 million C-band antennas that are used for individual television reception across Asia, along with about 60,000 antennas at Asian cable head ends and over 175,000 C-band VSATs used for critical telecom applications. More recently, we've seen how C-band has been used to provide critical broadband links for businesses and students trapped at home during the current COVID-19 pandemic. But the real issue that we talk about when we discuss C-band is the tug of war between the use of C-band frequencies for satellites versus terrestrial mobile services, principally 5G. Now, no one doubts the importance of cellular broadband. In fact, we are all deeply connected to our mobile phones, and we wouldn't give up the opportunity to get more capacity, faster broadband at lower prices. But the real question, and one we'll deal with today, is whether to get better, faster, cheaper mobile telephone services, do we need to give up satellite C-band? One of the areas that we'll focus on is the ITU World Radio Conferences, the WRCs, both past and future. It is at the WRC that global spectrum harmonization is attempted, and since the 2007 WRC, the satellite industry has had to fight with the cellular industry over the reallocation of our C-band spectrum to cellular services, which are referred to as International Mobile Telecommunications, IMT. We've had to fight this fight repeatedly, both at the ITU, at various WRCs, and at each country across the globe as they implement the decisions of these World Radio Conferences. The bad news is that the cellular industry has far more resources to fight this fight than the satellite industry. Nonetheless, we in the satellite industry have managed to limit the damage so far to reallocating only a portion of the extended C-band, 3.4 gigahertz to 3.7 gigahertz. And so far, we have largely been able to protect 3.8 to 4.2 gigahertz, which we refer to as the standard C-band spectrum. But getting back to the perceived requirement to give cellular, and in particular 5G, more spectrum. Before WRC 19, the total amount of spectrum that was allocated to cellular services varied from region to region, but was in the range of about 900 to 1200 megahertz in total spectrum. At WRC 19, 5G was allocated 17,000 megahertz of new additional spectrum. That's right, 17,000 megahertz across multiple bands, which means that cellular got an increase of spectrum of about 15 times more than they had allocated to them prior to WRC 19. And now the cellular industry is trying to get even more spectrum at the next conference, WRC 23. The new 5G spectrum that was allocated at WRC 19 were millimeter wave frequencies above 6 gigahertz, and they were naturally well suited for urban environments where 5G will in fact be rolled out. 5G will have low latency, supposedly 1 to 4 milliseconds, compared to over 20 milliseconds for today's 4G networks. 5G will have microcells, which will allow for significant spectrum reuse. And for high network density, 5G promises to support 1 million devices per square kilometer. And of course, massive machine type Internet of Things, IoT. C-band is useful to cellular operators for low density, wide area networks, spread out to cover suburban and rural areas, where lower frequency bands like C-band that cover large geographic areas with a relatively small number of cell sites can be built and operated at a much lower cost and as an alternative to the small cell millimeter wave spectrum with high frequency reuse. In other words, the reason why the cellular industry wants to use our C-band is because it gives them a cheap and easy way to roll out 5G services that are in many ways really just enhanced 4G infrastructure. But enough from me. Let us turn to our speakers. Welcome, gentlemen. Welcome. So starting with Mohanad, please introduce yourselves and your companies and give us your initial thoughts on C-band. Take it away.
Thank you very much, Greg, and nice to be here. Good morning, good afternoon, or good evening, wherever you are in the world. Thank you to ConnecTechAsia in association with GVF and Satellite Evolution Group for inviting me. I'm privileged and honored to be with such distinguished panelists. Intelsat is the company I represent, and I work in the Spectrum Policy Department in Intelsat. I'm responsible for our spectrum strategy for Region 3. Needless to say, Intelsat, the pioneer of satellite operators, is one of the largest satellite operators in the world, if not the largest. By far, we use the most C-band capacity, and we are providing growth, sustainable growth in C-band in this region, particularly in Asia. And this is a very interesting session that we look forward to taking part in. Greg, you mentioned in your very nicely eloquent introduction the benefit of C-band and why it's utilized in this part of the world, particularly with the inherent propagation characteristics. And I think this resonates with the regulatory authorities in Asia because, like you mentioned, the outcome from WRC 19, the position in Region 3 in Asia, in other words, was stable and it held firm in order to protect C-band. And that was evident by the fact that there is no agenda item to study downlink C-band across Asia. As a matter of fact, in the 3.4 to 3.6, there are some countries that have their names in a footnote for utilizing this band for IMT. So it's not a harmonized approach in this region, and that's because of the key propagation characteristics C-band via satellite provides, but also the critical services and the benefit it brings to consumers and benefits across this region. One of them is TV transmission, for example. The challenge from our side is it's almost out of sight, out of mind analogy. You see mobile handsets and terrestrial equipment near to you, and you see them on a daily basis, whereas with satellite, it's not seen. Therefore, it's almost more challenging to bring home the advocacy and the benefit that satellite provides to citizens. However, even with that said, I think regulators in this region recognize the value it brings and the benefit it brings to their citizens. And that's why in the outcome from WRC 19, there was no agenda item to study C-band in Asia in the downlink. I wanted to maybe perhaps bring one other argument to this debate, which is the economic realities of C-band. We've seen that in the past, mobile operators tend to require more and more spectrum in various WRCs since 2007 up to now. It's been, like you mentioned, a tug of war. But I think mobile network operators need to take a hard look at itself in regards to the necessity or the justification for more spectrum. One thing I want to highlight is a recent study that Ofcom, the regulatory authority in the UK, did in response to claims by MNOs that they needed access to at least 80 to 100 megahertz of contiguous spectrum. Ofcom researched the ability of mobile operators to launch 5G services after they've auctioned the spectrum. And they did the survey, and it found that there was, and I quote here, there was no evidence that 5G could not be delivered with smaller, example, 40 megahertz blocks or non-contiguous carriers in other frequency bands, i.e. spectrum that's other than C-band. And if you look at the realities, in most countries around the world, particularly in Asia, typically you have 3 to 4 national MNOs. So making 200 or maybe up to 300 megahertz available would be plenty of spectrum that is needed to provide the speeds that is needed for 5G. And the Ofcom study actually found that with 40 megahertz, you can deliver 770 megabits per second with just 40 megahertz. And this conclusion is actually backed up by real world observations of operators around the world who have launched high quality 5G services in less than 80 megahertz of spectrum. Just a few examples: Vodafone in the UK with 41 locations have launched 5G services with just 50 megahertz. EE in 6 cities in the UK with 40 megahertz of spectrum. So this notion that you need a huge amount of contiguous spectrum is really not showing in terms of the reality. So before auctions, there was a lot of spin. We needed X amount of spectrum, but now with the auctions taking place around the world, we don't see that. And this is an important matter because regulators need to take into account the risk of oversupply of spectrum. You risk saturating the demand for MNOs for additional spectrum, which leads to non-competitive auctions in many cases and lower auction revenue. And this risk spectrum that goes unsold or underutilized. In fact, I'm reminded of a study that was done by LS Telcom, which showed in this region in Asia, there is harmonized spectrum that is yet to be utilized and licensed by MNOs. And this is a trend that's continuing in other parts of the world as well. So regulators need to take into account this reality that do you really need that amount of spectrum to provide 5G services? You mentioned an important point, Greg, that satellite operators are actually have a stake in 5G as well. We like to see the promotion of 5G, because there is a role for satellite to play there. But it has to be done in a balanced approach in a way that does not impact incumbent services that are providing benefits to citizens in this region. And the reason why we're saying this is because we've seen from various ITU studies, but also local studies conducted by regulators, that sharing in the same geographical area is not feasible for obvious reasons. But fundamentally, the 5G signals can interfere with the FSS in two ways. One is to saturate the LNB of the Earth station, even when the 5G signal is adjacent to the satellite signal. And the other way is the out-of-band emissions of the 5G signals can cause in-band interference to FSS signals. So we are very cautious and concerned about the impact this will have. And we hope that the regulators can take that into account when making their decisions. And we're seeing that reflected in the outcome from the WRC-19, that in this region, there has not been a decision to study 5G services. And there are other alternatives as well. You can, like China is doing, re-auction 2G or 3G spectrum. That's a valid way forward to look at maximizing and efficiently using the spectrum that's available. And there are, like you mentioned, millimeter wave spectrum that's available right now to provide high capacity demands that is needed. But then you have to take into account the urban versus the rural areas, where you don't want to create a new digital divide between the haves and have-nots. And that's where power satellite comes in, to bridge that digital divide, to provide the cellular backhauling. We're already providing cellular backhauling as Intelsat to 3G, 4G MNOs. And there is a lot of work in the satellite industry. Intelsat is involved in this in 3GPP to develop within release 17 an interface between the satellite and the 5G component to have a space and a terrestrial interface between the two different technologies. So my final thoughts are that marketing promises regarding 5G services must be balanced with reality. Large geographical areas in Asia have not yet seen 4G rollout yet. And there needs to be a balanced approach between how much you can actually harmonize between the region and where you cannot harmonize. And you cannot force this harmonization if it's not possible. Seaband FSS satellites will continue to provide critical services and enable social economical growth across societies due to its resilience and its propagation characteristics. And repurposing of C-band spectrum for 5G needs to be done in a manner that does not disrupt important satellite services or undervalue the vital resources it provides, or undervalue the spectrum that is being looked in for auctions. So with that, I conclude my opening remarks, and I look forward to an interesting debate with my fellow panelists. Thank you very much.
Thank you. Yan-Hung?
Yes, great. Good morning, good afternoon, good evening to everyone, depends on the area that you stay in. Thank you for GVF and ConnecTech to invite me to this event. I would like to introduce myself. My name is Ye-Hung Chen. You can simply call my initial, Ye-Hung. I'm the manager of spectrum management in AsiaSat. I joined this company in 1995 and have been working for 25 years, all related to spectrum work. I've been involved in frequency coordination, regulatory work, and spectrum defense of the new user into the C-band. Isro is the first regional satellite operator in Asia since it was established in 1988. Our excellent assets, superior technology, and commitment to both customer service and long-term partnership have allowed us to achieve one of the market leader position. Enjoying industry recognition over the years, our accomplishment and proven expertise in satellite operation are driven by innovation leadership and insight into leading edge technologies and market development. Now we are operating 7 satellites in orbit, almost all of them carrying C-band, and providing service in the Asia Pacific market with enhanced powerful and efficiency. During my working period, 25 years, I saw the introduction of new service trying to use the C-band. Those including ultra-wideband devices, WiMAX system that date back to 2008, and as well as now is 5G. During the compatibility study, field trial test analysis is clearly showed that their operation, this new introduced application are incompatible with the FSS receiving system. With new introduction of the IMT in wide deployment manner, the satellite C-band have to find ways to avoid interference due to the introduction of this terrestrial usage. In preparing for this webinar, I will addressing 3 main points. First is how's the C-band situation in Asia, like I will pick Hong Kong case, and how's the future move, like in the WRC 23 new agenda item, and what could satellite operator to do on our own, and what are the initiatives that satellite operator in facing the IMT, taking out the C-band for their own use. In the Hong Kong case, I think people may be aware that it's from 1st of April 2020, it's allowed the new deployment of 5G public mobile in Hong Kong. And they have changed in the allocation from FSS to MSS in the 3.4 to 3.7 gigahertz. And 5G can only use now is the 3.4 to 3.6 gigahertz. While it's important to keep the 100 megahertz 3.6 to 3.7 gigahertz as the gap band. This is very important as long as we can make a filter with 100 megahertz gap band. That is the way that have to be compatible with the 5G living in the adjacent band. More importantly, that Hong Kong has imposed 2 restriction zones in typo area and the standard area. The restriction zone is very important that they can protect the co-frequency operations of while introducing the 5G in the same area. This is a difference from exclusion zone that we are often talking about. Exclusion zone means no 5G. Restriction zone means, okay, there may be some kind of consideration if they are compatible, or it's indoor use that they can, the local administrator can allow the usage of 5G. And important, the last point is that the Hong Kong administration offer a compensation to all licensed smart V owners. That is to retrofit their existing antenna system. That is the way that how Hong Kong is handling the introduction of the 5G in 200 megahertz at the lowest frequency C-band, while keeping 100 megahertz for gap band, and keeping the rest 3.7 to 3.8 gigahertz for FSS usage. Regarding the new items in the WRC 23, I think I have to alert that there are important 3 agenda items which will most likely will co-frequency operation with IMT and 5G. This is the agenda item 1.2, 1.3, and 9.1c. The 1.2 is a very key agenda item for region 2. This is asking for 3.6 to 3.8 gigahertz, 200 megahertz gap band identification for IMT in region 2. In 1.3, there will be asking for mobile upgrade from secondary to primary in region 1. And these 2 agenda items will provide very, very high pressure on region 3. For region 3 now, although it has mobile primary allocation, this mid of C-band 3.6 to 3.8 gigahertz has not been identified to IMT in the whole region 3. Unlike the 3.4 to 3.6 low frequency band of C-band, which has country footnote, Asian Telecom Authority may only consider to open this mid C-band 3.6 to 3.8 gigahertz to IMT, but not to assign them to 5G at this stage. Once IMT has been identified in region 2 and region 1 has asked from secondary primary to primary mobile, and much more that where it will give high pressure to have a new agenda item for WRC 23 to identify the mid-C-band to IMT in region 3. But in Mali, we are more worried. No one wants to get behind the development. And this is expected it will not last until WRC 27 to make the decision. And there will be concern that it will be jump in on the C-band, mid-C-band to be identified, to be used by IMT in region 3. The third item that I bring to this, in addition, okay, the second item, I missed the 9.1c. 9.1c, as long as you have to aware that this agenda item will have a very broad impact and come in different ways. And the proposal is not easy to understand as long as this is the impact is to bypass the discussion. Okay, there are still discussion in the WRC, but this one will apply to all frequency band, not only can be applied to all frequency band in addition to C-band, like the KU and KA. And instead, it is proposing to combine fixed and mobile, which means that there is the no discriminate that for administration that they can assign 5G whenever there is a fixed allocation. Okay. For the third item I want to address here is the initiative by the satellite operators. Initiative by the satellite operator, like in Asia, we have initiated to design a 5G rejection filter on our own. And Asia has developed this 5G rejection filter as a set of to protect our C-band satellite user. The filter is a device to be inserted between the feed horn and the LMBS and the satellite signal reception antenna. This 5G reception filter is designed to suppress interference signal from 5G base station and hence operate in adjacent band. The use of this filter can avoid the LMB into non-linear region or even saturation. As I said, you know that we are a satellite operator. We are not going to the equipment business. Our objective of this initiative is to do our part to protect C-band satellite users. We are so eager to keep our client on our using our C-band satellite, be protected from adverse changes of the environment of the 5G intrusion into C-band. And this is one of the major initiatives that we have contributed starting from 2018, mid of 2018. I mean, it's 2 years ago. And we have we feel that this will keep our client in our satellite feed, to using our satellite feed. And this is those are the 3 key points that I want to address in this webinar. Thank you.
Thank you, thank you. And next is Mark. Mark, of course, comes to us from the perspective of a user. So it should be refreshing. And if you could make your intro a little shorter than our other colleagues, it'll leave us more time for some Q&A. Thanks.
Sure, no worries. Pleasure to be here, everybody. As you said, so I'm Mark Wardle. I'm from Encompass Digital Media. Most of my career was in the UK until about 4 or 5 years ago, moving to Singapore. When I was in the UK, I ran BT's Media and Broadcast division. So most of my career has been in the media and broadcast sector, not particularly specialised in satellite. If we use all sorts of technologies, so satellite is a very important part, of course. So I came to Singapore, joined Encompass Digital Media in beginning of last year. So I've been about coming up for 2 years now, and taken over there as their operation in Asia Pac. So, as you said, Greg, I come from a user perspective. So maybe on the ground, literally, as compared to up in the sky. So Encompass, so I run the Asia Pac operation, as I say. Encompass is a media services provider. We pretty much anything you see on a live screen somewhere has probably come through an Encompass facility in one of the continents, all of the continents that we're on. We typically transmit something like 1,200 channels of live television. Estimates vary, but probably something like 350 million viewers see screens that are coming through through Encompass facilities, and we do everything from live sport, play-out services to general entertainment services. So the services that we transmit a huge impact, very, very visible to the general public. So obviously being in Singapore, looking at this, so we run from our facility in Singapore here, we have a satellite station, all C-band, and I've worked with the regulator here, the IMDA, quite a bit over the last year when they were going through the consultation period. And looking at what to do with the C-band here. And I think it's probably pretty, from a practical perspective, it's pretty clear that the extended C-bands that Mohammed mentioned at the beginning, that's the part of the band that I think pretty much has been agreed for use for 5G. I think from a practical user perspective, what you always need in these types of circumstances is some certainty. So you really want to see the industry associations, these types of conferences, ConnecTechAsia, Avia, those types of guys, lobby the standards bodies and industry to get some certainty. So actually, I looked from a Singaporean point of view. I thought actually we'd come to a pretty sensible solution here. Below 3.7 gigahertz has been handed over to 5G, and trials start from January next year, 2021. Which is all okay. There's also areas in Singapore which have been, there's been a couple of small areas which have been prohibited for 5G. They're very small. There are 2 or 3 other areas which are known as precautionary zones. And actually the Encompass facility is in a precautionary zone. And a precautionary zone, I think, Yahong, you mentioned the use of low powered or restricted power, maybe, or indoor 5G in those zones. So that's what's happened in Singapore. The problem we've got, of course, is that those C-band downlinks that we transmit, as I mentioned, they're carrying live sport, all the cricket to India, IPL, quite popular in India, I understand. They're all being downlinked in frequencies which are very close to that 3.7 kind of cutover. So we'll install filters and things on our downlinks, but there's downlinks, you mentioned, Greg, at the beginning, all across Asia. And so I think the key thing for me is we need certainty to do some planning, and we need to be able to work with our clients to say, that we want that C-band to be clear above 3.7, and we need coordination. So even if, and really just help and advice to our clients who are downlinking and affiliates downlinking these services to say that if you fit a filter, for that particular area, typically, it's a filter here cuts off at 3.65 gigahertz down at 45 dB rejection at that level. And I think if we could be certain that across Asia it was like that, well, then we could plan ahead. Malaysia are already talking about 3.8 gig being used for 5G, and that's going to cause a problem. So I think, for me, it's about using the standards bodies, using the industry associations, making sure that we've got certainty for all these, many thousands of users of very high-profile services. And I'll close on that note.
Thank you very much. PK, please.
Yeah, thank you, Greg, and good morning, good afternoon, and good evening to all of you. And thanks to GVF and ConnecTechAsia to provide me such a platform to interact with the all August panelists here on one of the hot topics, thanks to the WRC 23 agenda. So first, well, let me briefly say about my organization, Indian Space Research Organization, also popularly known as Isro. And of course, you might have heard of Isro quite a number of times, and especially when we became the first country in the world to successfully place our spacecraft on the Mars orbit. So ISRO is probably the only organization in the world that has end-to-end infrastructure and capability under one umbrella to manufacture all types of satellites, that is communication satellites, remote sensing satellites, and scientific or interplanetary missions, launch them into the different orbital slots, and also to run various application programs to utilize all these satellites. So we are the only organization in the world under one umbrella who takes care of all these activities. We have a fleet of more than 60 satellites that include communication, Earth observation, navigation, and the planetary missions. ISRO is under Department of Space, Government of India, which is the administrative ministry in respect of satellite systems as per the Government of India's rules of business allocation. So we do act as an administrative ministry. However, when it comes to the service licensing or operational license, there is a different department in India who handles those regulatory aspects. Coming to me, I have been working in Department of Space for more than 31 years in different areas, including Earth Station system design, development, system engineering and installations, VSAT systems, and also the satellite payloads and spacecraft configuration planning. Right now, I had the area of SATCOM planning and frequency management, including ITU activities at ISRO headquarters. I am also Vice Chairman of ITU Study Group 4, Satellite Services. So now coming to today's topic, Seaband. Very interesting facts were brought out by the previous speakers. Greg has, of course, covered the importance of Seaband in terms of its inherent characteristics in terms of the propagations, losses, and the wide area, wide service area, wide coverage footprint of the satellites, and hence the cost per bit and so on. And of course, Mohamed also has rightly pointed out the various alternative applications of the C-band in the terrestrial communication area, which are being envisaged, and then some of the concern for the protection of the satellite services. So I would highlight all these aspects when I talk about the scenario in India as far as C-band usage is concerned. Now, as we know, the C-band is mainly very important for the heritage services, because this is since when the satellite communication really came into being, the C-band started providing the services for the telephony and the television. So in India, the heritage services like television broadcast, cable head-end, and the VSATs, they have been operational in our various satellites. And also some of the mission critical applications like telemetry tracking and command. We have the ranging for the navigation, our own navigation constellation. We have the feeder links running for the mobile satellite services, for the, we call it data relay transponder, DRT payloads, for the search and rescue payloads, for our navigation payload, for the meteorological services, and of course for the strategic services. The feeder links is still, the C-band is continue to be used very widely. Now, when we come to the pure statistics, now today, if we go for the space segment, now we have 40 satellites with partial or full Indian coverage over India. Now this includes the Indian satellites as well as some of the other operators, foreign operator satellites. You can imagine the extent of the commercial opportunities which C-band provides. And only in over India, there are 40 satellites, and out of which 22 satellites with more than 200 transponders are being utilized in India. Rest of the satellites do have the coverage and they are waiting for the opportunities. And out of which 22 satellites, 11 Indian satellites with wider Indian global coverage are providing the services. Now, this is what is the amount of investment which has gone into the only space segment. Now, coming to the ground and user segment. Of course, most of this capacity of around 200 transponders, 60% capacity is for television. Now, in India alone, we have more than 900 satellite TV channels which are permitted, private satellite TV channels, out of which around more than 300 are the pay channels. When we come to the number of the multi-service operators and local cable operators, we have 6,000, more than 6,000 registered MSOs, that is multi-service operator, and more than 60,000 are the local cable operators. And out of which 13 MSOs have more than 1 million subscribers. And overall, 117 million cable TV subscribers in India alone using C-band services. You can imagine. When it comes to the VSATs, more than 300,000 VSATs in KU and C-band together. Of course, Greg has told that more than 175,000 in C-band in the Asian region. So India is the second largest television market in the world with about 197 million TV households. And every one of them depends on C-band today for the television. So when we talk about the protection, now having invested so much, it is directly impacting the common people's lives in terms of even the mission critical services, or even for the national security as well as the disaster relief and management operations. It becomes utmost important that the services are protected. But at the same time, we being the government agency, we are also aware of the fact that the spectrum, being a scarce resource, has to be utilized optimally. So if there could be the additional or alternate services could be incorporated, could be accommodated without impacting the existing as well as the future growth in satellite services, why not? Why not permit it? Why not explore? So we are not averse to doing the coexistence studies, do the analysis, and then taking cognizance of those studies, take the action. And this is what is the approach of the government of India has been. Now, Mohan had also told that as when we went for the WRC 23 agenda, WRC 23 did not in fact, identify the C-band for the region 3. India was one of the countries who played a major role in identifying the WRC 23 agenda items. And I think most of the panelists were part of it during the discussions. So we should not talk about only 5G services, number one. That is another point which I wanted to bring it out. There are services like now the unlicensed Wi-Fi, which we call it NRU also, which are also being discussed. If 5G is not possible, IMT is not possible, whether Wi-Fi, unlicensed Wi-Fi can be accommodated in C-band. Why not to explore it? We are doing that. In India, we have been carrying out such studies. Of course, taking cognizance of the other studies, which already was done. Greg has mentioned in 2007 also, there are some studies were done in WRC 2007. And there are ITU reports available. The 2015, some reports were there for both uplink and downlink. And the initial possibilities are those, if you go for the outcome of those studies, it would be difficult to coexist with the IMT or 5G because of the various reasons, cumulative aggregate interference reaching to the receiver, satellite receiver. There is already, again, it was mentioned by Mohamed that the blocking of the LNBs when it comes to the downlink, there are out of band emission which acts as an in-band emission to the receivers. So there are keep out distances which are coming in the hundreds of kilometers when you go for the interference, short-term or long-term interference. So we have to take into cognizance of all those studies which were done, of course, quite a long time back. Now today the technology has improved. 5G has come up with the active antenna systems. Probably they could use for the, already they are talking about usage of ASS for more than 6 gigahertz. So we have to see and maybe the best way forward from my suggestion would be at this point of time that all of us should participate in the ITU studies in various ITU forums and bring out the concerns of the satellite operators in case we find in those studies there are certain protection mechanism which needs to be involved, or whether whatever is not possible or possible. And even one voice in the ITU forum can change the decisions of the WRC or even the ITU. So it is very important that all of us participate in all the forums of ITU studies. Now the studies are going on, the parameters are being identified, and then only we can really do the justice to our organization, to our countries, and to the citizens of our country, because ultimately both 5G, IMT, terrestrial, satellite, everything is important for the population. Thank you so much, Greg, to give me this opportunity. And I will be looking forward for the very interesting interactions. Thank you.
Thank you. Well, what time we have left? So to jump right into it, gentlemen, in view of the fact that a couple or several hundred megahertz have been reallocated from satellite C-band to IMT, what's your view of the use of C-band for 5G? Is that more than sufficient? Mohamed spoke about contiguous versus non-contiguous and the quantity that cellular operators need in order to be able to deliver 5G services. What's your view of that? And more broadly in that context, what's your view of the future of satellite C-band in Asia? Is it going to continue to be indispensable for media video distribution? What about for data, VSAT, and broadband? Are we looking at something that's sustainable for both IMT and for satellite users, or are we going to see our spectrum whittled away over a period of time until there was none. Mark.
I suppose probably, Greg, I'd just say, you know, a lot of that depends on time, and I think the, you know, over a long period of time, you know, if you went forward, say, 10 years or something, you know, maybe all these video services by that point are delivered over IP networks, you know, but that's going to be a very long time away, and it varies greatly depending on which geography you're in. I think I'll probably just bring people, one thing I would like to say, I think, is if you come back to the very short term, you know, this has been sort of, you know, it gets discussed in, you know, all the various industry fora, the standards committees, WRC and that type of stuff. But for these 5G tests start in January 2021. Right, so there's going to be people switching on 5G terminals in 3 or 4 months' time. And that's actually going to start causing some problems without a doubt, you know. So I would say to people that are using Seaband, even if you're above 3.7, and particularly if you're close to 3.7, you know, maybe within 50 or 100 megs of it, then you should be looking at putting filters or taking some kind of protective measures, because otherwise, you know, we can talk about long-term effects, but I think there's going to be some pretty short-term ones as well, you know. I think I'll probably go back to my original point, and that's, you know, make sure that we get some certainty and say, okay, at least if we say it's above 3.7, fine, but take some protection and take some action fairly soon, you know.
Yeah,
Right.
if I may just come in here as well, just to echo what was just mentioned by Mark. To answer the question by Greg, first of all, I think from an MNO's point of view, more spectrum is always a good thing. You know, they'll always want more, 100, 200, 300 megahertz. Obviously, that's a good thing for them. But what is actually really needed? That is a fundamental question that regulators have to decide. Do they really need up to 100 megahertz contiguous to provide 5G services? We don't think so. Based on Ofcom regulatory outcome, they don't think so either. Based on reality in auctions that have been taking place around the world, that's not reflected either. So this is the fundamental question that the administration in this region really need to answer. As for the future for satellite, I think that the propagation characteristics, the ability to bridge the digital divide, in other words, provide content and connectivity wherever you are, as farther you are from an urbanized infrastructure, would not change the cost of delivery if you were using satellite means, but it does include additional costs if it was an infrastructure. So this is the balance that the regulators have to take into account, how to ensure that their citizens are connected. So taking a holistic approach, encompassing a different mixture of technologies, is the way to go. To Mark's point about the current near-term realities, I agree that regulators need to see, customers need to see regulatory certainty. They need to ensure that what is their service quality of service in the next near term. And there are mitigation techniques. AsiaSat has been very good at promoting their filter technology and what they've been doing with customers. Intelsat has been working with their key customers as well, also with the regulatory authorities, to actually provide the policy narrative for the regulators when they come to auction their spectrum. Here's what you need to do. Examples. You need to have a guard band, because a filter cannot operate without a frequency separation. Okay. And these kind of things have to be taken into account by the policymakers before they actually put the roadmap for how 5G will be enabled. And this is where the regulatory certainty is important.
Mohammed, just on your point there, I think I'm not an expert in 5G networks by any means, but I think probably to your point about the contiguous bandwidth, you know, mobile networks by their very nature frequency hop and hand off, and they're agile, and they're, you know, the satellite bands are not. You know, they're fixed. So the mobile guys have got a lot of technology readily available at their disposal to hop around if there is broken sections of bandwidth, whereas the satellite industry simply cannot do that.
That's right. And another point you actually bring up is the ability to share spectrum. Today, satellites do share spectrum by frequency, orbital separation, and coordination. MNOs have not yet shared their spectrum, and this is an additional cost because you have to put base station and infrastructure for each MNO. Whereas if you can have one base station and you can have the ability to share, especially with MIMO technology, this could be a possibility. So these things have to be taken into account. And I think the regulators fundamentally are at the center of answering these questions.
All right.
Yes. Yan-Hong, you had some question? I mean, answer?
No question, but I want to share, as Marcus say on the fast changing of this 5G, as long as the frequency is changing from one to another, from one country to another. Actually, Asia says this initiative to making the filter is contribute to our client operators, and this we already make 8 types. You know, it's increasing. We are creating a new type in the very soon in the next month, and then trying to capture. We are monitoring very closely on the Asian countries what actually they allocate. This is for the short term. This is absolutely for the short term. For the long term, we need to stop the propagate the use of 5G going up the band. That's why in this webinar I have bring out the WRC what 3 on the agenda item 1.2, 1.3 that we should look at, and this is a very key important that don't let them go up to 3.8 or 3.6 to 3.8. This is a middle C, I can say, middle of the C-band, and we are trying to encompass them to operate at the lower band. Now the damage is damaged already. I think it's some countries in Asia has been identified in the footnote, but in the long term, we cannot allow them to further expand. But you know that high pressure from outside, this is not our control. I mean, that's why we need to encourage everybody to, in this satellite community, to participate, to look at the WRC 23 agenda item, what's happening in the next region, and then keep going on the Asian area, that we should not following the same, like in the WRC 15, or the last day. Why is that something changed? I mean, if you were there, then the IMT want to identify the C-band or the C-band or part of higher than 3.6 for IMT. But at the last day, there was no conclusion on that. We are very happy on looking at this kind of result. Thank you.
BK, do you want to add something?
Yeah, Greg, I would like to add 2 points in this. See, one thing is the why at all they need the spectrum, because that was your first question, whether really that spectrum is required and it is adequate. So, of course, we do understand that the requirement of the spectrum is for the providing the bandwidth hungry or meeting the bandwidth hungry operations, like that is for the millimeter wave bands and all that thing. They are using it. They want it for the basically to meet the bandwidth requirement. But they also need the spectrum for the covering the larger area and ranges, long ranges, and for which they have to go for the lower frequency band. And that is how the pressure is coming on the C-band. But there are C-band, S-band, L-band. There are bands are available which have already been identified by the ITU for the 5G. And as far as C-band is concerned, of course, like in India itself, we have identified 3.3 to 3.6 gigahertz. And I think that should be adequate as far as, because we have coupled with the S-band and L-band also identified for the IMT. But what is another, the aspect which is worrying, that the identification or demand of the specific frequency band for 5G is driven by the availability of the devices and the chipsets, and which is again being manufactured by the companies beforehand without even doing the necessary coexistence studies, or without even going to the identified body like ITU or WRC. And afterwards, having developed or having started and having invested, the pressure comes on the other services, the other primary services to vacate the band for the accommodating the 5G. I think this is, we need to really handle this very judiciously, because this cannot be the reason to identify a frequency band because some of the companies have invested the money in developing the devices, or some of the countries have started deciding or even considering the using this particular band. So we should respect the mandate of the international body, that is ITU, for identifying those frequency bands whenever any new service is there, with due protection to the existing services. So this is what point I wanted to make.
Well, listen, thank you very much. I had hoped we could go into answering the question of who should subsidize the costs of these C-band protection filters and so forth. And beyond that, who should pay for the C-band capacity that becomes stranded and unusable when the services are forced to be turned off. But unfortunately, we've run out of time. And so we'll have to leave that. And other questions, I had pages of questions. Oops, invisible questions. So I wanted to say thank you to Mohammed, to PK, to Mark, and to Yahun. It's been great. And thank you all for listening. Please send your questions and we'll get back to you.